Okay, complex numbers, unit 2, day 1. Make sure you have your notes out. So some vocabulary. The complex number whose square is -1, that's just the imaginary unit. So I is the imaginary unit. I equals the square root of -1, which means I squared equals -1. Very important. You need to remember that I equals the square root of -1 and I squared equals -1. Any number of this form where a and b are real numbers and b cannot equal 0 is an imaginary number. So that's like 4 plus 3i. That would be a plus bi. That's what that is right there. Okay, so maybe write that down. Right, a plus bi. Okay, that's going to go away in just a second because, yeah. The set of real numbers and imaginary numbers is complex numbers. And the number a plus bi is a pure imaginary number if a equals 0 and b does not equal 0. Again, that's just pure imaginary number. So that's just bi. Okay. A plane similar to the coordinate plane, blah, 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 blah. This is where you graph imaginary numbers, is the complex number plane. The distance from the origin on the complex plane in general is the absolute value of a complex number. So that's the absolute value of a plus bi equals a squared plus b squared. That's important. Just make sure you have that formula written down. And then complex conjugates are a plus bi, a minus bi. So the sign just switches. Okay? Okay, let's do some more vocabulary stuff. So for any positive number a, let's look at this. So we need to find the square root of -a. Negative a is the same thing as -1 times a, right? Which is the same thing as the square root of -1 times the square root of a. The square root of -1 is I, so that's I square root of a. Okay? So real numbers here are a plus 0i. So that's basically just any number, 1, 2, 3, 4, 5, continue on forever. It just doesn't have the imaginary in it. Imaginary numbers are a plus bi, where b does not equal 0. And then pure imaginary numbers are just bi. So that's like 3i, 4i, 5i, 6i, so on. Okay? Now let's get to graphing these. So let's look at a. So the horizontal axis, the one that lies flat, is the real axis. The one that goes up and down, the vertical axis, is the imaginary axis. So in graphing these, let's do the real first. So if we look at a, we have 2 plus 3i. I'm going to go over 2 on my real axis. Okay, then I'm going to go up 3 on my imaginary axis. That's where point A is. Okay, do B. So it's 4 minus 3i. So I'm going to go over 4, down 3. That's where point B is. Okay, for C, we don't have any real numbers, so I'm just going to stay at 0. I'm going to go up 2 because it's 2i. That's where C is. Then the last one, D, I'm going to go minus 1, so left 1, plus 0i, so I don't move at all. That's where D is. Okay? Now let's simplify these. Okay, so if we look at this one, -12. So that's the same thing as -1 times 12, which is the same thing as the square root of -1 times the square root of 12. The square root of -1 equals I, so that's I squared to 12. Now we just have to break down that 12. So I'm just going to make a factor tree out of it. 3 times 4 is 12. We have to break it down more. We have to break it down to the prime factors. So 3 is a prime number. 4 can break down further to 2 times 2. Okay, and when you take something out of the square root, you have to have 2 to take it out. So we have 2 2's, which means I can take out a 2, so that's 2i square root of 3, because the 3 was the only thing left on that tree. Okay, let's look at this next one. So the square root of 25, the square root of -25. Well, that's the same thing as -1 times 25, which is I square root of 25, because the square root of -1 is an I, so you just pull out that I, break down 25, that's 5 times 5. I have 2 of those. I can pull it out, and I'm just left with the 5i. The square root goes away because there's nothing left there. Okay? So finding sum or difference. Basically, this is the same as adding and subtracting polynomials. on addition, you're just going to combine like terms. So that's 7 minus 3, and then the negative 2i plus I. So just combine your constants and combine your imaginary numbers. 7 minus 3 is 4. Negative 2i plus I is negative I. So the answer there is 4 minus I. Okay, on B, we have to distribute that subtraction sign first. So that becomes plus negative 3 plus 2i. Okay, and then you just combine like terms. So 1 minus 3, and then 5i plus 2i. 1 minus 3 is negative 2, 5i plus 2i is 7i, and you're done. Okay, pretty straightforward. Just a couple more. So let's look at this first example, 7i times 3i. That's the same thing as 7 times 3 and I times I. 7 times 3 is 21, and then I times I is I squared. Remember, I squared equals negative 1, so that's 21 times negative 1, which is negative 21. And you're done with that one. Okay, now let's do the 2 minus 3i times 4 plus 5i. So I'm going to do this one by distribution. So I'm going to multiply the 2 to the 4 plus 5i, and I'm going to multiply the negative 3i to the 4 plus 5i. When you multiply that out, you get 8 plus 10i minus 12i minus 15i squared. Then remember, I squared equals negative 1, so I'm just going to plug that in for I squared. So then that's 8 plus 10i minus 12i minus 15 times negative 1. Negative 15 times negative 1 is positive 15, and then I just combine my like terms. So 8 plus 15 is 23, 10 minus 12i is negative 2i. Okay? And then for this last one, I'm going to use the box. You could do it by distribution, you could do it by the box. I just want to show you both ways. So this is a 2 by 2 box. I have negative 4 and 5i on top, negative 4 minus 5i on the side. Then you just find the area of each box. So negative 4 times negative 4, positive 16. 5i times negative 4 is negative 20i. Negative 4 times negative 5i is 20i. 5i times negative 5i is negative 25i squared. And then we're going to combine our like terms. So you get 16 minus 20i plus 20i minus 25i squared. I squared equals negative 1, so plug that in. You get 16 minus 20i plus I plus 25. The 20i's cancel. 16 plus 25 is 41, and you're all done. Okay, keeping it short and simple. Please take the quiz, and I will see you guys tomorrow in class.